In this lesson, we're going to learn lots of different ways to graph lines, but we're going to start with a method called making a table of values. The first thing you'll want to do when you graph a line by making a table of values is solve the equation for y, or rewrite it in function form. After you've done that, you're going to make your t-chart, which is a table of values, and you're going to pick several numbers for x. It doesn't really matter what you pick. You can be strategic if you have fractions or decimals in the equation and you're trying to cancel those out. But really you can pick anything else, anything that you want for x, and then you calculate the y's, and those become the ordered pairs that are on your graph. You plot those ordered pairs and you connect them with a line. So here's an example. We're going to graph the equation y plus 2 equals 3x by making a table. So we make our t-chart. We often will pick the numbers -2, -1, 0, 1, and 2 kind of as the most common numbers picked for x, unless for some reason something else is easier because of fractions or decimals. And then what we end up doing is following through those steps that we mentioned before. The first thing we're going to do is solve the equation that's given to us for y. And then that equation is what we will use to calculate the y column in the table. So one at a time, our x is our -2, -1, 0, 1, and 2. One at a time, we're going to be plugging those in for the x in the equation that we just wrote, the 3x minus 2. So for example, when we plug in the -2, 3 times -2 is -6, and -6 minus 2 is -8. So when I plug in a -2 for x, I get out a -8 for y. And that's my first ordered pair, -2, -8. So I plot that. Then I continue. The next number I'm plugging in for x is a -1. 3 times -1 is -3. -3 minus 2 is -5. So when I plug in a -1 for x, I get out a -5 for y, and I plot that point, -1, -5, as the next point on my graph. And then I continue doing that. So next, when I plug in a 0 for x, 3 times 0 is 0, and 0 minus 2 is -2. So I plot the point 0, -2. And then when I plug in a 1 for x, 3 times 1 is 3, 3 minus 2 is 1, so I plot the point 1, 1. And then last, when I plug in a 2, 3 times 2 is 6, and 6 minus 2 is 4, so the ordered pair 2, 4 is on my graph, and my answer is the line that connects all of those points. Remember that lines go forever in both directions, so you'll extend it and you'll put arrows at the end to show that. Next, we're going to look at graphing horizontal lines and vertical lines. This is somewhat counterintuitive. The y-axis is vertical, but when you graph an equation that looks like y equals some number, you end up with a horizontal line. And the x-axis is horizontal, but when you graph something that looks like x equals some number, you end up with a vertical line. The way that I make sense of this is that I go back and use the tables that we did earlier. So if I start with the equation y equals 4, and I try to make a table for that, there is no x in that equation. It just says y is 4. So that means in my table, no matter what x is, y is 4. And then I just pick a few random things for x because it doesn't matter what x is. The only thing that matters is that y is 4. So when I plot those points like 0, 4, 1, 4, -2, 4, they end up all being on this horizontal line. Similarly, if I made a table for x equals 2, there's no y in this equation. I don't know anything about the y's, but I do know that x is always 2. And again, I'll pick some random things here for my y's, but I do know that x is 2. And then I go to plot all of those. I plot 2, 0, 2, 5, 2, -5, and I see that they're all along this same vertical line.